Our next speaker will provide insights on the Data Center Global Horizon, Chang Tsann. He is the Practice Director leading the Data Center Facilities Practice for Dell's Infrastructure Consulting Services in the Asia Pacific and Japan region since 2009. His key role at Dell is to develop and enable the capabilities and solutions of its data center consulting services to Dell customers in the region. The service offerings include data center planning and management, data center facilities efficiency, and data center design and build turnkey solutions. Please welcome him with a huge round of applause.
Hi, good evening everyone. I'm Chang Tsann. It's a pleasure to be here in Mumbai today, and it's good to share with you guys on what Dell is doing in the data center area. And today I'm just going to walk through a couple of slides to just give you a snapshot of what's a global trend, some of the snapshot on new design, new consideration that companies and and a lot of end users and operators like you are looking at as well in other parts of the world. I'm sure those of you who came in earlier, you saw a lot of videos, a lot of this new innovation that Dell has brought to you, right? In the video earlier, for those of you who have seen, we have actually worked with big technology firms like Microsoft, eBay, and so on, right? Looking not only on the IT infrastructure, but looking at the modular data center solution as well. Okay, so just to begin with, today is that I just want to share this picture, right? A picture paints 1,000 words as well, right? And just want to maybe take a look at this diagram of two photos here from 2005 to 2013. Anyone want to maybe give a guess or maybe share what you see in this diagram or this photo here? How can you tell? Anyone? Mobile internet has transformed, right? It has really transformed the digital economy itself, right? Right. So you can see is that this is just illustrating in 2005 when the Pope Benedict was assigned as the Pope of the Catholic world, right? So that was the time where you see that the transformation from 2005 to this year when Pope Francis took over, right, after his resignation. You can see that there's so many devices that people are holding up here, right? Whether it's a smartphone, tablets, or whatever you have there, they are all connected to the digital economy, right? The digital age itself, right? And at the back of this is that this is really pushing it back to the back end infrastructure that I'm sure all of you are now working on. Your hands is really touching on all this infrastructure, right? This is the data center. The data center is actually driving the whole new age of whether it's the mobile, the internet era, or the new digital era itself. As I say, I was very pleased to be here again because I remember the first time that I been to India. That is probably my first trip in 1995. Right, in 1995, when I first came here, I was figuring out, meddling a lot on on the modem, right? The modem at that time is about 600 BPS to 1200 BPS. That's very good enough, right? Even if you actually gradually get to 9006 and so on, right? And you guys should know, right? I think a lot of you would know that telecom infrastructure is a challenge in this country. And back then, it has been, right? So today, actually, when I was here in the hotel and I was working, right? And it was so easy that I just took up my phone and I just connect to the internet device, right? And I can actually use this at the hotspots and so on and have my laptop working and continue to work on my Outlook, and other activities itself. So the digital economy has transformed, right? And these are the drivers, right? And I'm sure you guys are one of those that actually contribute to all these applications that's out there driving the internet age. Right, 2.4 billion of you, including you guys sitting here, are driving all this. Okay, and this is continue to grow, right? And with this application, right, this is all on the cloud, right? What does it imply here is that the investment, right? Investment is continuing to increase, right? And really here is that the power is one of the key enablers, right, of the data center infrastructure. Over the years, you can see that it has continued to grow. And it will still continue to grow. It's still one of the inhibitor in terms of meeting all these challenges, right, where you have some area where your power grid is not sufficient to meet some of the demand of the data center capacity. So what you see here is that over the last 3 to 5 years, there has been a lot of improvement in terms of optimization, utilizing of energy efficiency and so on. The rate has slowed down, but no doubt with the digital age that is still charging forward, the momentum of the increase is still there. With this is that I think at the back of your mind here is that all of you are going to continue to invest. Right, you continue to invest, and this is a data from Data Center Dynamics itself that shows that investment in data center is about 14%, right, 2012 to 13. And the red box over there is showing all the facility, right, the facility investment worldwide, okay, and the black box is looking at the growth rate itself, and the gray box is the outsourcing, IT outsourcing and so on. Right, over India, I read an article, I think the growth is about 9% for Indian economy, for data center. So what does this mean for data center infrastructure itself, right? So data center has over years evolved, right, just like the modem that I talked about, right? A tiny little modem of 600 BPS that's now transformed to a wireless kind of device today, right? So the data center in the earlier years, right, it has been, you can see in the legacy world is that there's not much of maintenance or not much of design is taken into consideration, right? Because it's a very low density, you can just put in a computer room, and back then you just call it a server room or computer room, right? But today, as we evolve, we find that you need to make sure that your data center is optimized, right, in terms of the airflow efficiency. So in the middle here, you see that in the 2000 to 2010 in the time period is that people are looking into how to optimize the data center using a lot of this containment strategy, right? Containment strategy to make sure that you're utilizing the best airflow design without recirculation and so on. And of course today, containment is a de facto design standard in a lot of data centers. And today we are looking at more innovation, which I will share with you in terms of how data center is moving with a more innovative solution in cooling as well. And a lot of this cooling solution is supported by a lot of the architectural changes in the compute environment. Also, one of the trends is that a lot of data centers, especially the larger ones, you can see a lot of that in the Google News, right? Google is find that Microsoft, Yahoo, and Google's they are building large data center farms. Every 3 months or so, you find one news about all these data centers are getting very low efficiency, high efficiency with low PUE number, and they are more and more going chillerless, right? And I think the key point is not whether it's chillerless or not, right? The key point is that a lot of this driver is coming from a lot of the code of conduct that is driving the industry to change the behavior of data center. The code of conduct dictates that you need to cut your carbon footprint emission into the environment, right? You need to come up with a very efficient, not just on the PUE, but you're also looking at the CUE and also the WUE. So some of these industry trends on the code of conduct or the ASHRAE standard and ESTI are driving the changes of behavior in data centers. So what Dell is doing is that we also support the industry in a number of ways, and this is a snapshot of showing the new server product specs that Dell has came up with to support high ambient temperature operation. Okay, what this means here is that the inner box that you see is that with the current new generation of Dell servers, it support support the temperature operation up to 35 degrees Celsius. Okay, 35 degrees Celsius, and also a wider range of the humidity from 10 to 80, right, for continuous operation. So that actually extends your capability of server inlet temperature, right, in your data center. And what does that mean? It means that you do not need to have the same amount of cooling, right? How many of you today in your data center have a supply temperature of 20 degrees or less? There are still, right, a couple. Or how many of you having 20 to 25? Many of you. I think this is kind of a norm, right? But 25 to 30? Nobody, right? But there are people already designing that. I just want to tell you that is that we have designed data center that is between 25 to 30. Although here say 35 I'm not suggesting that you stress the environment, right? Because your environment has a lot of different kind of equipment. Okay, not just on the server, you have storage, you have network, legacy devices, and so on. So depending on your environment itself, is that you now can actually operate at 25 to 30 degrees, and we have designed data center that runs at 28 degrees. Okay. Now this diagram also shows you that the excursion that Dell allows you to go to 40 degrees and 45 degrees C. And 40 degrees C is up to 10% in a year. 10% in a year is 900 hours. And then 45 degrees is about 1% in a year. That's about 90 hours. So it gives you that flexibility to actually design your data center to ride through some of the thermal excursion in your data center during an outage. Right? So these are some of the design considerations that you can take advantage. And Dell is not doing this by itself, right? And Dell is doing this because the industry, again, I say, is pushing for it, right? The ASHRAE is actually in 2001 has actually published a new expanded range of guidelines, right, for IT equipment. For IT equipment, right? Not for Dell equipment, for IT equipment. So when they say for IT equipment, they have actually expanded the range from used to be a classification they call A only, right? And they now have A1 to A4. So A1 to A4 give you a different category that does a lot of these studies worldwide as well. And this is showing you that when we look into the expanded range, we also study the climate in America, Europe, and also in Asia. And we came up with this result to show that with the expanded range of operation, there's the possibility to run high ambient temperature operation has now increased. Right? The top one is the, you can say the legacy, but the bottom one is kind of the future, the expanded range of operation. You can see that it just expand. If you look into the Indian subcontinent here, the range has now expanded. It allows you to have more possibility, that possibility to do a lot of energy saving, redesign of your data center to take advantage of the kind of new architecture there. Right? So these are some of the advantages or studies that we've shown that on the CapEx side, you can save up to 3 million per megawatt of IT load. Right? And also in terms of your operating expense, because you are running less on your crack units, right? Your air conditioning and so on. You are also redesigning your thermal right through, right, for your crack units and your fans and so on in the data center. That actually saves you about 100 to 275K per megawatt of IT load again. So these are some case studies that we have done. So I kind of share with you some of the high ambient temperature operation, energy efficient servers, right? What are the other aspects that you can see what are the new design considerations that may also take advantage of this is that we also look into modular solution approach, right? So one of the modular approach here is forget about your traditional cracks or your cray units or your air handling units, right? Look into modular solution like the fan wall, where you can see here is that the fan wall is like a group of cells, right? A group of cells, and each cell is an EC fan itself, right? With single EC fans as well, if you build it, once you form a fan wall unit itself, right, the efficiency and also the utilization, right? The utilization of surface area that you can maximize your airflow to the data center has actually improved. So we have actually do this in a number of data centers in Asia, in China as well. Is that this is a data center floor. We have designed 3 sections of fan wall units, and these fan wall units are providing redundancy in the way that each of these cells is pluggable, right? You can plug it out and replace it with the, another module. Someone in your facility guy can do it himself, right? You don't have to call a vendor to do it. Okay, and these fans actually take up less footprint, less noise, and a couple of other advantages. So this is one thing that you can look into, the adoption of new design consideration. The other thing that also on the data center floor is that to meet some of the flexibility and agility of your business, right? Time to market, right? A lot of customers is now looking into in terms of faster deployment, speed to deployment of their IT infrastructure. So what I'm showing here is the micro module itself, right? It's a micro module in a way is that it's just a set of IT racks with some power and cooling solution integrated, right? Integrated with a containment module itself, right? Self-contained. You can put it in almost any building or any environment, right? You just need to provide with power and a chill water supply if it's running on chill water. The key advantage of this is that this is all prefabricated design, right? It's designed, then prefabricate, and then pre-tested and commissioned. Once it's completed, it actually, from the factory, you actually put in a truck and load into your data center itself, right? And you can see that, from there you're actually doing assembly like a Lego blocks. You are not doing site engineering or site preparation work. No weldings or pipings or anything, right? You just want to go there and plug it and just fix it in. Right from there, you can see is that from this diagram. In this example that we have done, it takes about 2 months to deploy once the PO is issued. Okay. Other consideration in terms of cooling technology as well. This is talking about indirect air exchange, right, for air side economization. Okay, so the trends that you see just now in the video earlier on, you can see that a lot of the modular solution now is taking a lot of the outside air technology, right? Outside air cooling technology. So this one itself is also taking, in terms of the heat transfer, is taking along the heat wheel itself. The only thing is that there's no direct exchange of air, meaning that there's no contamination and of pollutants, right? Reduce that itself. I think in China and also in India, as I go across the region, is that you see a lot of pollutants itself, right? So you want to minimize the direct exchange of air. So this is one of these solutions that reduce that kind of impact, right? That you still will be able to do this outside air technology to the data center. In this example, we are able to optimize up to 80% in the year, right? About 7,600 hours in the year to run on that economization mode. So these are some of the technology, and the last one that I have here is also looking in terms of containment system, which we should talk about earlier on. But this containment, we call it the optimized containment system, is that it provides you agility and flexibility to your environment as well. And let me explain, right? You can see is that when it's brand new, it's an empty shell, right? Empty shell, right? As you populate the racks your server or your storage, you can push it in. And once it's populated, right, you enclose it, this becomes the hot house. The environment is the cold house environment. So you can see that it's just as you need, as your demand come in, you grow, you contain the enclosure itself. Of course, you may say if it's not full, then you can actually put blanking panels that actually will be able to enclose the whole enclosure itself, right? And the also smart thing about this is that this has infillers here. The panels that allow you to adjust according to whether it's a 42U rack, 52U, or a storage equipment that is wider than 600, right? Or it becomes 800, right? So all this is allow you to be adjustable to your requirements. Okay, with this optimized system itself is that we are able to get about less than 4% of leakages, right? Meaning that the airflow there is pretty efficient, right? Airflow. So all of you today are running data center, whether you are running data center or you are utilizing and so on, you will be looking at driving the next power engine in your data center. How do you look into enable your data center, right? Next generation. I want to summarize here, and these are the few key factors that you need to look into. You need to look into and in your next consideration of your data center, whether as an end user, as a provider, as a designer, and so on, right? So one of them is really look into highly optimized, efficient servers, right? Or even storage as well, right? This will give you the maximum compute per watt, right? And then high ambient temperature operation, take advantage of that. If you are running 20 degrees C today, as you refresh your server architecture, you should be able to take advantage of increasing your set point temperature itself. Advanced cooling technology, I shared two examples today. One is on the fan wall, and another one is on the heat wheels, right? These are new trends that you can adopt. Optimized containment system itself, right? This is a very agile, flexible containment that meet your demand as you grow in your data center. Micro module is also a prefabricated modular data center IT infrastructure that allow you to deploy to your data center floor as you need as well in a shorter time period. It's all pre-designed. So these are some of the considerations that you may want to look into. And this will actually look into how you can optimize your IT or your data center capacity, and or even looking at maximizing or optimizing your energy consumption there, right? And at the end of the day, all of you want to run an efficient enterprise, right? That will actually drive the digital economy more efficiently, right? All of us would be able to take a smartphone or a tablet and so on, whether it's at home, anywhere, right? At home, at work, and so on, you will enjoy the digital economy that we all are using today. Last one here is just to wrap up here. At Dell itself, we have been running this consulting for 4 years now, since 2009. We're going to the 5th year. We look into a lot of services portfolio itself within the data center consulting in terms of planning, management, facility efficiency, and also design and build turnkey solution. Okay, I won't elaborate in details on all this, right? My next colleague that is going to come up here, Mr. Som Shekhar, will be able to share with you all the details, what we are doing here in India as well. So I'll leave you here with my contact, right? And later on, if you want to find out more on some of the specific trends and architecture or design, I'm pleased to speak to you as well. Any questions before I hand to Mr. Som Shekhar? Yes?
So I've heard about free cooling a lot, but I haven't really seen any of the large colo players globally move to free cooling. One from the likes of Equinix. Do you know any of the large colocation service providers switching to free cooling? KDDI, NTT, Equinix, HSL, a lot of guys who build their custom DCs do free cooling, but I haven't seen any of the colo guys.
Colo, because free cooling, you have to look into a lot of consideration is on location strategy as well, right? Free cooling does not mean that you can implement it anywhere you like, because you need to, first of all, look into the return of investment of the architecture in terms of the climate, right? And look into the hours of operating that you can do. And of course, a lot of colo may not be providing that today because they are considering that a lot of customer are, number one, either still conservative, very traditional, right? Because and of course, number two is that their server architecture and so on are still legacy that may not be so tolerant to some of these free cooling solution out there as well. But I think what you say, I think in North America there are companies that are taking advantage of some of this free cooling mode itself, right? And I think this will continue to evolve. Thank you. In Tencent is not a colo, right? But I can talk about Tencent. Som was talking about this as well. So we did project for Tencent, and you guys know Tencent? Tencent is one of the largest operator in China, right? Providing internet service provider, right? In terms of gaming, in terms of chatting and all the internet services. Like in China, you don't have Facebook, right? So they have Facebook-like applications and all this that's provided by them. So we have actually designed data center for Tencent for about 56 megawatt of IT load, right? And that itself, we actually designed some of these free cooling solution in China. They are in northern part of China. I think we calculated up to about 70% of the years that you can take advantage of some of the cooling. So some of the solution that we discussed here, like the fan wall and so on, we actually implemented there as well. Any other questions? Okay, let's welcome Shom Shekhar here. He will explain more in depth in terms of what we do in India. Okay, I'll speak to you guys later in the drink session. Okay.
Thank you, Mr. Chang.